Unreal's newest update, Unreal Engine 5.5, just released, and it is a big deal. The reason why is the brand new lighting system called Megalights. Since the start of computer graphics, lighting has been the most important part of any 3D render or game. Physically accurate lighting can make the difference if an image is realistic or not. When Unreal Engine 5 released, it introduced a lighting system called Lumen, which gave us real-time global illumination. Global illumination is bounce lighting, which is the extra light created from light rays bouncing off of surfaces. For example, if you have a room with a single light from a window, the room shouldn't be pitch black. Instead, a light from the window will bounce around and illuminate the rest of the room indirectly. And the less light we have, the less bounce lighting. Lumen was a game changer when it released, since it was real time. Before Lumen, to get bounce lighting, we had to wait for each frame to render. Now it is all instant. And while this is great, we still have an issue, and that is each light source requires a lot of processing power to render. A single light in Unreal needs to calculate the bounce lighting and shadows from the light's perspective, which is a very computationally expensive process. This means that we are limited in the amount of lights we can use. If we use too many, then our game's performance drops dramatically. This was a huge limitation until now. In UE 5.5, a new lighting system was introduced on top of Lumen called Megalights, which removes this constraint, allowing us to have as many lights as we want. To demonstrate, in UE5, I'm in an environment that uses hundreds of individual lights. I'm running at 5 frames per second. My computer cannot process this many lights. Now with one button press in the settings, I can enable Megalights, and boom, instantly my frame rate jumped from 5 frames per second to 40. And what is incredible is that I didn't have to make any changes to my environment. All I had to do was enable Megalights, and it worked right out of the box. This is revolutionary. It unlocks huge creative possibilities that simply was not possible before. Now we can have near infinite lights, perfect for environments like the ones you see on screen. On top of that, textured area lights can now cast dynamic light rays and soft shadows. This simply was not possible beforehand. We can have realistic lighting from large dynamic area lights like TVs. Megalights works perfectly with Nanite geometry, which lets us have infinite detail and polygon counts. This means we are no longer constrained by most real-time rendering limitations. We can have as many lights or high polygon objects that we want. On top of a lighting upgrade for UE 5.5, metahumans have gotten two big new features. The face animations you see right now are not motion capture and they are not hand animated. Instead, the face animations are generated by AI, with the new audio-driven animation feature. All I did was upload the audio of myself talking, and Unreal automatically created the lip sync for me. There was no camera needed for my face, but of course the rest of my body is still motion capture. You can imagine this will be helpful in a game with a lot of dialogue. In addition to that, we now have the option to use optimized metahumans, which are a lot less computationally intensive and take up less memory than the default metahumans. If you have tried metahumans before, you know that they take up a lot of disk space. The average metahuman is 950 megabytes, which is almost an entire gigabyte needed for each person, since it uses a lot of 8K textures and complex skeletal meshes. While this is okay for cinematics, for most games you probably don't want to waste an entire gigabyte for a character, which is why we now have the option to download a game-friendly optimized metahuman, which instead of 1 gigabyte has been reduced to just 60 megabytes. And it still looks amazing. The quality drop is not noticeable. It is crazy how much characters have been optimized, and it makes using them possible on less powerful computers. Unreal's sky system has been improved dramatically. By default, Unreal comes with a set of volumetric clouds, which means they are real clouds that exist in the environment. You can fly around them, and they realistically interact with the lighting. Before volumetric clouds, to create a sky, we were forced to use a skybox, which is a massive box or sphere that surrounds the entire world with a sky texture on it. This was able to get the job done for most environments, but as soon as we have a dynamic sun that changes time and position, it becomes obvious that the sky is a static texture. This is why in recent years, games have introduced dynamic skies with volumetric clouds that are physical objects in the environment. They realistically interact with the world and lighting like any other object. The best example of this was in Red Dead Redemption, which has a full time of day and weather system. Every cloud you see are 3D renders. None of them are textures. The last version of Unreal Engine 4 introduced volumetric clouds and the atmosphere system. This made creating realistic skylighting a breeze since it physically simulates the Earth's atmosphere and engine. All you have to do is drag it into your world and you immediately get real sky. Moving the sun will change the atmosphere's light dispersion, automatically updating the color. In fact, when using it, if you move the camera far enough away, you can see it simulating the atmosphere of an entire planet. The only issue, in my opinion, was that the default clouds it came with looked terrible. They feel like big globby mushrooms and less like something you would see out in the real world. Now the clouds have been updated. Here is before and here is after. The clouds look a lot better, and we have more control over them than ever before. There's a slider to change the amount of clouds, and we can transition the sky to become a chaotic storm. Another improvement to the sky is a built-in time of day sequence. Real-time day transitions are pretty common in a lot of games. If we wanted one in Unreal, we had to either buy one from the marketplace or create our own. In the past, I programmed a time of day system from scratch, and it could get pretty complicated fast. Now UE5 has a built-in time of day that we can easily control from the toolbar. The daytime is able to transition to night with the sunsets, and the moon and stars become the main source of light at nighttime. All of its properties are handled by the timeline, so we have complete control and we can animate it. There is a really great feature called vertex painting, which lets us paint on meshes and blend between different materials. It gave us a lot of creative control in the editor, but it stopped working on nanite meshes. 5.5 introduces the new nanite mesh painting, which brings back the same feature for material blending, and it works perfectly with nanite displacement. You can see the geometry changing in real time. Thousands of polygons are being generated automatically. With this, we have complete control over the nanite geometry of our environment, and it opens up new 3D workflows. There is no sponsor for this video, but if you like it, make sure to subscribe for more Unreal Engine videos in the future. It would mean a lot because the channel is almost at 500,000 subscribers. In the last version of Unreal Engine 5.4, it introduced the motion design editor to make the process of creating animations easier. It was specifically made to help users of other programs like After Effects or Cinema 4D transition to Unreal. As part of this editor, in UE 5.5, we get a new material designer that allows us to create and animate complex materials with a layer system directly in the engine. Since Unreal Engine 3, the engine has been based off of a node system. A lot of programming is done with nodes instead of code. Even the material editor uses nodes. This is great because it gives us a near infinite amount of possibilities. We can create our own advanced materials, but the majority of our materials are not going to be that complex. Materials for the most part are simply made up of 4 textures: a base color, roughness map, metallic map, and normal. The complexity of a node-based material editor isn't necessary. This is why in 5.5, we have a new alternative to the material editor, because the material designer now supports creating physically based materials with a layer system, very similar to the layer system you would find in other programs like Photoshop and Substance Designer. This kind of workflow is very familiar to most computer graphic artists and can be a lot easier than stringing a bunch of nodes together. With the material designer, you can select any object and create a material. New to this version is each channel, like the color, roughness, and metallic, have their own layers. For example, in the color channel, I could change the first layer to be a solid color, then add a new layer on top of it with a texture mask to hide part of it. And then I can edit the layers of the roughness separately to break up its reflection, with grunge and scratches. This can also edit existing materials. If you have all the textures, just drag it in and it will automatically know what textures belong to each channel. We can start using the layer system to modify it quickly. There has been general improvements to Lumen lighting across the board this update. Hardware ray tracing is now significantly faster, with a goal of achieving 60 frames per second on current gen consoles. Global illumination now supports hit lighting, which produces more physically accurate bounce lighting. My favorite feature is a new noise reduction algorithm for reflective surfaces. Previously, when it came to metal surfaces, the reflections can look really noisy. Now in UE 5.5, that noise has been almost completely removed. Every new version of Unreal is a huge leap forward for graphics. Unreal's animation tool, called Sequencer, got some upgrades. In case you don't know, Sequencer is UE5's timeline, which is where we create and keyframe all of our animations. Now we have access to advanced deformers like lattices, which are featured heavily in other animation programs like Blender. With these deformers, we can morph the geometry in real time. For example, moving any of these points will change the statue's geometry. We can also animate it to create some crazy deformations on characters and objects that previously we couldn't do. There's also a squash and stretch tool, and you can program your own deformation tools for specific animations. The sequencer's user interface is much more usable with what Epic is calling a dynamic interface. Most of our cinematics end up having a lot of tracks, so we can now isolate certain tracks to just focus on them, hide other tracks, or filter for specific objects, for example seeing all the lights currently being animated. Added in 5.5 is animation layers on individual controls. This means that we can quickly edit existing animations by adding new animations on top of them without changing the originals. This functions exactly the same as they do in Maya. For example, this vampire scream looks weird because the head is looking down, not facing the camera. By selecting the head and adding a new animation layer, I can move the head up to face the camera. Now the animation is a lot better, and I can control how strong or how much effect this layer has. Color grading is much more straightforward with a user interface that is very similar to dedicated color grading programs like DaVinci Resolve. Previously, all of our color grading adjustments had to be done in the post-process settings, and it can be very confusing making such fine adjustments in a small window. Now all the core settings to edit the color, like the saturation and white balance, are exposed in an easy-to-use window. The path tracer is now production ready, which means it is fully featured and no longer in beta. It finally supports volumetrics, which are your fog and clouds. Previously, we couldn't use volumetric clouds in the path tracer, we were stuck to textures. Now everything is supported, and it has a new denoiser which makes rendering images faster. This just touches the surface. You can check out the release notes to see everything added to the engine. Also, don't forget to like and subscribe for more Unreal videos. Unreal is more important than ever, because half of all next-gen games are being made in UE5. There is no better time to learn Unreal Engine than now. Luckily for you, I have an entire free course right here on YouTube, which goes over the essentials to learn UE5. You can learn how to create this world you see right now. You can check it out, link in the description below.